Hello students, good morning. Welcome to this module number 2. We are going to discuss about failure of materials. In that we are going to understand the two concepts. One is the Gibbs rule and another is the effect of alloying of elements on steel properties. So let us start with this Gibbs rule. Okay. Okay, so the phase rule, or commonly known as a Gibbs rule, okay, this will be expressed mathematically and in general relationship for the existence of the stable phase corresponding to the equilibrium conditions. Okay, so this phase rule also we derived from the thermodynamic states, that is P plus F plus C is equals to P plus F is equals to C plus 2, where P is the number of phases and C is the number of components and F is the number of degree of freedom, and 2 stands for the number of variables. Okay, means that is the system variable. Either one is the temperature and pressure, so which are able to change depending upon the phase. Okay, so this Gibbs phase rule indicates the number of phases that can coexist in equilibrium in particular system. And also using this rule, it is possible to determine the whether the solidification process takes place at a constant temperature or within the certain temperature interval or not. Okay, this Gibbs phase rule also we can give an equation. One is for the change of binary, that is the two component phase diagram, wherein the pressure is assumed to be a constant at 1 atmosphere. Hence the digit of 2 expressed in Gibbs phase rule to replaced by digit 1, that is which stands for the temperature as the single variable being a constant. So that modified of Gibbs phase rule will becomes P plus F is equal to C plus 1, or also we can write this one as F is equals to C plus 1 minus P. So what is that C plus 1 minus P? That should be greater than or equals to 0. So since the degree of freedom cannot be less than 0. Okay, if or the P is less than C plus 1, which means that the number of phase in a system cannot exceed the number of components in a system. Okay, that is a plus 1. Okay, that is the variable. Okay, these are all about the Gibbs phase rule. Next, let us will discuss about different concept of this effect of alloying elements on steel properties. Okay, this effect of alloying elements on steel properties. Uh, so we'll discuss. So steel is an alloy of iron and carbon. Already we know that. Okay. In addition to various alloying elements are added in a small proportion to obtain the desired property of the steel. Okay. So this affects various of alloying elements of the properties of steel are we can discuss now. So initially, first one alloying element of the steel is carbon. Okay, so what are the properties? Okay, so the carbon is the most important alloying ingredient of steel, and because it has a direct effect on the physical properties of steel. And also what happened, considering the amount of carbon content which forms the factor for the difference between the steel and cast iron. So steel with low carbon content has some same property as iron. Okay, the soft but easily formed. So as the carbon content increases, a metal becomes harder. So acquires this a greater tensile strength, so and becomes increasingly respective to heat treatment with further development of the strength and hardness of the material. Okay, so however it increases in carbon content, the lower the ductility of steel. Okay, and making it more brittle. So what happen if the brittle means it will having a strength of that material, and which maximum amount of carbon content in steel also it will be around 2%, and above this 2% of steel transforms the cast iron. So this is about how the effects of increasing the carbon content or alloying element in the steel. And next we'll come to the manganese. Okay, the manganese is the next important to carbon, because it functions both deoxidizer as well as to impart the strength and responsiveness of heat treatment. Okay, so manganese is usually present in acquired quantities from zero point 0.5 to 2%, but certain special steels are made in the range of 10 to 15. Okay, this is how some of the cases, because depending upon the usage of that steel, their alloying element will be taken for 10 to 15 minutes, 15 percentage. And then we'll discuss about the chromium. So already you know that chromium was one of the most response of heat treatment material to increase the response of heat treatment. So it imparts good wear resistance and high hardness. So however, this chromium decreases the machinability and hardening of temperature range unless balanced with the nickel. The most of the nickel or chromium based alloys certain point 0.5 contain 0.5 to 1.5% chromium. When chromium addition exceeds 5%, the high temperature properties and corrosion resistance of steel are greatly improved. So while additives of this percentage of chromium, so definitely that the improvement of steel, it will be improved, means high resistive property will be increased in the steel. So and it will be less corrosive as compared to previous, because as we consider the chromium, so the increase the resistance of the corrosion on that material. So this is about the chromium material, chromium. Okay, I'll come to the next material, that is nickel. So I already know that increases the strength and what we call toughness in steel. So however, it has least effects on the hardness of steels. So in addition to that, the ranging from 1 to 4%, although for the certain applications, the percentage has increased or high as 36% are used. Okay, the steel containing nickel usually have a more impact resistance, and especially what we call low temperature applications, and certain stainless steel or employs the nickel is up to 20% also. So this is the additive the addition of that content in the steel, so that will be improve the impact resistance. And next one is we'll discuss the copper. This is the copper is general thing, you know that material, and normally this is added an amount of 0.15% to 0.25% to improve the resistance to atmospheric corrosion. So and to increase the tensile and yield strength with only the slight loss in ductility. So what we have to do for this copper, so higher strength properties can be obtained by perception of this hardening the process. So this is about the copper. And the titanium. So titanium is one in which stronger the carbide former. It is a strong the carbide former, and it inhibits grain corrosing, what we call corrosioning, and acts as a grain refiner. Okay, and it is usually added in what we call the 18 to 10%, 18 to 8% stainless steel, that is 18% of chromium and 8% of nickel, is going to improve the harmful perception of chromium carbides. So in some cases it is also added to a low carbon steel to make them more suitable for proclaiming the annealing. Okay, so this is about the titanium material. And for again the boron, if you take suppose boron also one of the effective of one of the alloying element on steel. That boron is added to steel in an amount of around 0.005 to 0.003% to improve the hardenability. So in combination with these other alloying elements, the boron acts as a intensifier, so increasing the depth of hardening and during the quenching. So due to its high cost, it is added in very small quantities. So these are all some of the effects of alloying elements on steel properties. So even along with this, lead will be there, sulfur will be there, aluminum will be there, silicon will be there, tungsten will be there, vanadium will be there. For these are all the things are alloying elements on steel with changing their properties or improve the properties. Okay, so I hope you understood this concept of various effects on what alloying elements on steel we discussed, and other things we will discuss in the next video. Thank you.